Perfect. So, dear guests, good morning, good afternoon, and good evening. A very warm welcome on behalf of ABB Energy Industries. My name is Barbara Levantini-Aloy, and I have the pleasure to introduce today's webinar. In today's session, we will hear how current surges caused by paralleling a generator in non-synchronized conditions can have destructive effect on power plant generators and substations. From a plant halt to severe mechanical generator damage caused by extreme electromagnetic forces. To prevent any disruption and to reach the highest level of safety, productivity, and availability, a reliable synchronization solution is what is needed. Before we get started, let's take a quick look at the logistics of this webinar. All participants are kept on mute. The presentation, as you have seen, is being recorded and will be made available in a few days on the ABB Energy Industries TechTalk page, and you will also receive it directly in your mailbox as soon as available. Should you wish to submit questions during the webinar, please use the Q&A box you find on the right side of your screen. You will find two options, a chat function and a Q&A function. We kindly ask you to use the Q&A option so we can make sure we can track all the questions that are coming through. Also, a little disclaimer before handing over to our main presenter. The information we're sharing today may be subject to change without further notice. ABB does not assume responsibility for errors or consequences of software or hardware described in today's presentation. Finally, I'm pleased to introduce today's speaker. His name is Werner Zimmerli, Global Product Specialist for Synchrotact, part of the global ABB Excitation and Synchronization team. With that, Werner, over to you. Thank you.
Thank you, Barbara. And welcome also from my side. And thank you for giving me the chance to talk about Synchrotact 6 today. First of all, I would like to give you some information about myself. My name is Werner Zimmerli. I joined in ABB Excitation and Synchronizing Department in Turgi in Switzerland in October 1989. Throughout these years, I hold different roles in engineering, sales support, and product management. Today, I am a product specialist for our Synchrotact synchronizing products. By the way, the picture on the left is old. It shows me from about halfway between my start at ABB and today. If you want to know what I look like today, you can watch the video picture. So let's start. I will begin briefly by introducing you to the world of power plant synchronizing and explaining why Synchrotact 6 is the most efficient way to keep your assets synchronized and productive. We will then look at 3 standout features of Synchrotact 6. After this, I will give an overview of the Synchrotact 6 family and present our global service network that provides fast and expert support. Naturally, I welcome any questions you may have about the product and our support program at the end of my presentation. So what means synchronizing of a power plant and why is it needed? Synchronizing means to automatically synchronize and parallel generators with power lines. Power plants and substations contain many valuable components essential to the reliable delivery of electricity from the power plant to the transmission grid. A synchronizing system shall protect these assets from the potentially destructive effects of current surges caused by paralleling in non-synchronous condition. In the picture on this slide, you can see such a rough power plant drawing with the turbine and the generator unit on the bottom left, the excitation system on the bottom right, and the turbine controller here. The energy will go here through the generator breaker to the external high voltage grid. So the Synchrotact is positioned here, as you can see in the circle. And in order to synchronize, Synchrotact has to measure the voltages on both sides of the open generator breaker. This is marked with blue arrows here. Then, if in order to adapt the voltage and speed of the generator to the network, it is sending signals to the excitation system for the voltage and to the turbine controller for the speed or frequency. If the two voltages are synchronous, then the Synchrotact is sending or issuing a command in order to close the generator breaker. If an asset, say a generator or power transformer, were to be disabled due to paralleling in non-synchronous conditions, it could shut down the plant or substation down for months. This, as you know, could cost millions of dollars in new equipment, lost revenues, and grid penalties. It would also damage the company's reputation for reliability. Some solutions of synchronizing require either each circuit breaker to be equipped with its own synchronizer. That equates to many synchronizers. Other solutions provide a synchronizing function integrated into a more complex system, resulting in higher complexity and a related reduction of functional safety. With the third approach, one dedicated synchronizer is used to synchronize all or a group of the circuit breakers in a plant. This solution often represents the best compromise between safety and cost. The life cycle of an electronic components is shorter than the plant life cycle. What can be done to ensure the long-term reliability of a plant? Well-known reliability calculations are based on constant failure rates. For example, the MTBF. This is shown in the picture here, the black line. And the MTBF for electronic equipment ranges from a few decades to more than 100 years usually. This doesn't take into account that, in fact, the failure rate of each product actually follows the red-marked so-called Bass-Youth curve. So in the beginning, when a product is new or a component is new, due to early failures, increased failure rate is to be expected. But this drops then down very fast to a low, constant failure rate, which is here marked with phase 2. This is the normal operating window. And in phase 3, in old age, the failure rate rises again significantly. So if the MTBF of a device is 100 years, given with 100 years, and it is assumed that the failure rate is nearly constant within the first 20 years of operation, this means only that the failure probability is about 20 divided by 100 or 20%. After 20 years, the probability of a failure increases with subsequent loss of plant reliability or availability. So based on this insight, safety-relevant components such as electronics of synchronizer should be replaced after a certain period of time. This means that the already known curve starts to run again after a replacement. As you can see here in this picture in the middle after 20 years. This improves the average failure rate and availability of the plant is optimized. You can see here the improvement from the gray line with one device or one component over 40 years and with a replacement after 20 years. In order to achieve optimum plant availability, we recommend as a practical guide the replacement of the electronic components after 20 to 25 years. Of course, such a date has to be coordinated with the lifetimes of other equipment, of the remaining equipment. The optimum is achieved when the operating times are built of equal lengths. It means in this example, we see an operating time of 40 years, and when the replacement takes place in the middle, that would be the optimum. Now coming to the application. SYNCHROTACT 6 is not a new product or technology that no one has heard or tested or used. On the contrary, SYNCHROTACT has been on the market for more than 55 years. It is the market and technology leader with more than 24,000 units sold, and it is now in its 6th generation. This is important in an industry like power generation and transmission, where widely proven, reliable and well-established products are preferred rather than new technologies where the risks are greater. Crucially, all 5 previous generations are compatible with SYNCHROTACT 6. They have the same housing dimensions and electrical connections. That means you can easily upgrade to the latest technology and the latest version at low cost. The main application is automatically connecting the generators to the grid that you have seen some slides before. A special variant of this application is synchronization of a coasting down machine. In this case, voltage and frequency matching is not possible. The machine is brought to overspeed by means of a converter. Then the converter is disconnected, the machine excited and starts to coast down. Paralleling occurs when the machine frequency falls through the line frequency. Another application for SYNCHROTACT is for manual synchronization. Manual synchronization is often used during maintenance or in emergency case. It is done by the operator by means of synchronizing instruments, and also typically these are double voltmeter for the voltage, double frequency meter for the frequencies, and the synchroscope showing the phase angle difference. Then the operator can adjust the voltage of the generator to the network voltage by giving raise and lower passes with push buttons, and the same for the frequency to the governor. And when the voltages are synchronous, the operator gives the closing command to the circuit breaker. In this case, SYNCHROTACT 6 is working as a so-called synchro check. That means it is monitoring and blocking a closing command from the operator in case it would be given in the wrong moment. Two lines can also be paralleled automatically by SYNCHROTACT. The lines can be synchronous or asynchronous. Most probably, the phases will not be coincident with synchronous lines, but this is due to load conditions. With synchronous lines, we have the lines can be connected somewhere else, but the circuit breaker, the local circuit breaker is open, and due to the load conditions, there is a phase difference angle, and the SYNCHROTACT has to decide whether this angle is within the tolerance band or outside. And for asynchronous lines, it's similar, but however, in this case, the lines are not connected to each other, so you cannot say whether the phase angle is at standstill or turning slowly or turning fast. And it is possible to define a criteria whether it is better to wait for phase coincidence, or if it needs a very long time to close as soon as all conditions are fulfilled. Now, how does SYNCHROTACT work? Internally, we can divide the process of auto-synchronizing into 4 different functional blocks. First is measuring, then matching, monitoring, and command generation. The measuring block is having the 2 voltages on both sides, from both sides of the open circuit breaker, and calculating the characteristic values used for the synchronizing process. The matching function, for example, is using the delta U, for example, the voltage difference or the frequency difference, in order to calculate adjusting pulses for the AVR and the governor, in order to match the values to the line. The monitoring function is comparing these actual values with the set maximum values in the monitoring function. And if all the conditions are fulfilled at the same time, the check release signal is given to the command generation function. And the command generation function finally is responsible to issue the command to close. And it is not given the command as soon as the conditions are fulfilled, because when the value is entering the allowed range, first it is on the worst allowed in the worst allowed position, and then it goes to the optimum and is going again on the other side of the tolerance band. So it is calculating the optimum to give it exactly with phase coincidence, and taking also into consideration that there is a delay time between the command when it's leaving the Synchrotact and closing of the circuit breaker. So what makes Synchrotact 6 different? Synchrotact 6 has 3 standout benefits. First is safety. As I mentioned a few minutes ago, Synchrotact 6 protects from the potentially destructive effects of power surges caused by paralleling in non-synchronous conditions. Second is flexibility. With 20 parameter sets and 8 analog inputs in a single device, one Synchrotact 6 can synchronize up to 20 generators or circuit breakers. This delivers a unique level of flexibility optimization at much lower cost. That means one device instead of many. Third, Synchrotact 6 secures the plant lifecycle. For those who already use older Synchrotact equipment, it is made easy to upgrade to the latest version from previous generations. The housing is the same size in all generations except for Synchrotact 4, which is a little bit smaller. And the electrical connections are also the same. Therefore, the plant's life cycle can be secured with minimum effort and cost. In the following slides, I will go deeper into how Synchrotact 6 meets the challenges of safety, flexibility, and securing life cycle, and the benefit it delivers while doing so. As you know, under no circumstances should a circuit breaker be closed in non-synchronous conditions. The consequences could be devastating. It can damage equipment and even injure people. Synchrotact 6 prevents this from happening. It is the only synchronizer on the market to have a diverse dual-channel design. If one channel should produce a potentially dangerous failure, the other ensures that the safety function remains intact. Each channel is made by a different vendor using different hardware and software. The two channels monitor each other to pick up the first sign of possible malfunctioning in the other channel. Even so, the two channels are made by different vendors and use different hardware and software. They are 100% compatible. They are designed to work properly together. And the design complies with the IEC 61508 SEAL Level 2, International Standard for Functional Safety. Nothing could be safer. So it is similar to Synchrotact 5. Synchrotact 6 uses the 2 out of 2 safety architecture, in which each of the two channels must agree to close the circuit breaker, otherwise it will not be closed. So if one channel is malfunctioning and wants to close when it shouldn't, Synchrotact 6 will not issue a command and the plant remains safe. This is called fault tolerance. Thanks to the Synchrotact 6 fault-tolerant design, using two separate and differently structured channels, both channels cannot be affected by random or systematic failure at the same time. Compared to Synchrotact 5 again, the safety concept has been improved with Synchrotact 6. Synchrotact 6 both channels monitor each other to identify the first signs of a possible malfunction. In addition, channel 2 is a fault-tolerant system itself, thanks to the use of a dual-core CPU, which operates according to the lockstep process. That means both cores run the same program and are doing every single step in the software in parallel. If one core does not follow with a step, the system automatically locks. This safety concept is supported by a comprehensive set of diagnostic functions, such as self-test and supervision functions for CPU and memories, then hardware memory protection, and detection and correction of corrupt programs and data. SYNCHROTACT's second standout benefit is its unique flexibility, which translates into a considerable cost saving compared to conventional synchronizing solutions. Typically, a conventional solution requires each circuit breaker to be equipped with its own synchronizer. That equates to many synchronizers in a power plant. A single Synchrotact 6, on the other hand, can synchronize all the circuit breakers in a power plant all the circuit breakers in a power plant. If the breakers have different capacities, and even if the breakers have different capacities and parameters. This reduces cost by up to 70% compared to conventional solutions in terms of the number of synchronizers you need to buy, engineer, to commission, and to maintain. No other synchronizer offers so much flexibility. The 20 parameter sets of Synchrotact 6 can be used in different ways. One parameter set, this is the traditional way, can be used for each circuit breaker with individual settings for the circuit breaker, governor, AVR, and so on. The example on the right shows the synchronizing of two generators with a total of 5 circuit breaker generators, circuit breaker 1 and 2, high voltage circuit breaker 1 and 2, and a tie circuit breaker which connects the two units together. And you can see on the example of generator circuit breaker 1, for example, that parameter set 5 is used with individual settings for this circuit breaker, for the AVR of generator 1, and so on. It is also possible to use more than one parameter set for one circuit breaker. For example, in a pumped storage plant, there might be a different behavior between speed control in turbine mode and in pump mode. In such case, two parameter sets can be used with individual settings, for one for turbine mode and the other for pump mode. Our third standout benefit is that Synchrotact 6 secures the life cycle of the plant or substation. It has the same size and the same electrical connections as previous generation, with the exception of Synchrotact 4. This makes it easy and cost-effective to retrofit. This is important because the life cycle of electronic devices is shorter, as you heard before, than that of electrical or mechanical equipment. New, not compatible versions can require more engineering in the cubicle or electrical room, which is costly. Several thousands older Synchrotact 2, 3, 4, and 5 devices in operation are slowly approaching the age at which a replacement can be considered. As a manufacturer and connoisseur of these devices, ABB offers functionally equivalent replacements with Synchrotact 6 devices. ABB's support begins with the synchronization device itself. It has to be functionally equivalent, compatible electrical connections, and mechanically identical installation sizes. In addition to that, ABB can offer the following support for the replacement work. We have a free delivery of standard replacement drawings. You can see an example or an excerpt of it on the right side here. This is a part of a connection drawing of Synchrotact 5 in black color. This is from the manual, a standard drawing, and drawn in with red color how to connect the Synchrotact 6 for equivalent functionality. This is available for almost all of our old devices in order to make it easy to replace it. But in addition, of course, this has then, if it comes to a project, then there is a plant drawing where Synchrotact 5 or 4 or 3 is drawn. And there we can provide, ABB can provide how to connect the new Synchrotact 6 in this, according to this drawing. And so we can draw in with a red color, for example, how to do that. And then also, of course, ABB can help or do mounting, connection of the device, commissioning, and preparation of the device drawing after commissioning, also to have a new valid plant diagram. As an example, I would like to show you a Synchrotact 4 to 6 upgrade project carried out in a power plant near Berlin. The Synchrotact 4 redundant dual channel system on the left-hand side here was supplied at that time together with a terminal row. You can see that here, and the standardized wiring between terminal row and the two Synchrotact devices. Let's say this was the standardized or internal wiring, and the external wire have been connected to the terminal row here from the bottom. And you can also see from the front here, there are two switches, one 3-position selector switch in order to bypass one of the two in case of a problem. And a second one is to stop a running synchronizing process in case for any reason it cannot be completed. And so what we did is we are replacing the wire, in addition to the Synchrotact devices themselves, of course, we are replacing the internal wiring and using the same terminal row with the same external connections. On the right-hand side, you can see how this was done. First, on the top, you can see that easily that the devices are bigger than the Synchrotact 4. And we have, for this reason, we had to place the two switches below the two devices, but the same functionality is still kept. And on the lower picture, you can see the same terminal row with the same external connections. And what we did is just to replace the wires, the internal wires to the Synchrotact 6, between Synchrotact 6 and the terminal row. Now this slide shows roughly an excerpt of Synchrotact 3 and equivalent Synchrotact 6 types. With the Synchrotact 3 dual channel system, it exists of two identical channels, not diverse. In case of a failure, one of the two channels can be bypassed. But since there were only a total of two channels, in case the operator would bypass the healthy device, there was a safety risk. Compared to that, with Synchrotact 6, the equivalent type SYN6302 is having two devices with each two channels, so a total of 4 channels, and 2 of them could be bypassed in case of an error. And even if the wrong one would be bypassed, then still there is one healthy channel in the loop. Going back to the single channel solutions, you can see we have here 6201 single channel device and the 6202 diverse dual channel device. They have exactly the same size and also exactly the same electrical connections. So in cases where the Synchrotact 3 single channel was used and an evaluation of the safety concept shows that it makes sense to have more safety, it can be replaced by the dual channel device instead of a single channel. There are no further costs than the price difference between the two devices, which is negligible. For the Synchrotact 4, it looks similar. We have the same dual channel with bypass function, but also only 2 channel with the if the wrong is bypassed, it's a safety risk. It can also be improved with that. And also the single channel device could be either used with a single channel device or with a dual channel device based on what is required or what makes sense. Since the SYNCHROTACT 5 was introduced in January 2000, the oldest devices are also now approaching the end of life. These products are still available, but as they are replaced by its successor SYNCHROTACT 6, in case of a replacement, an upgrade should be considered. The compatibility with SYNCHROTACT 6 is here the closest of all legacy SYNCHROTACT products. Finally, you can see that upgrades are easy, and if you want to replace, you are in the best hands with ABB. Now it's time to come to the product family. I already mentioned some codes. We have a total of 4 types with SYNCHROTACT 6. One type is the SYN6200. This is the SynchroCheck, and then we have the 6201, which is an automatic single-channel synchronizer. The 6202 is an automatic dual-channel synchronizer, a diverse dual-channel synchronizer. So all the 3 have exactly the same housing and the same connections. Just a functionality difference between these 2, and there is a hardware difference because here we have 2 microprocessors in the same device. And finally, the 6302 is the redundant automatic dual channel. It is in fact like 2 times 6202, but building together one system. It is treated as one device, and it is physically separated. And this makes it easy in case of an error in one of the 2 devices. It can not only be bypassed very easy, the defective device could also be removed from the cabinet or from the point where they are mounted, and the other device can remain there and can be used in a normal way for automatic or also for manual synchronization until a replacement is there, and then we can go back to the normal operation. For all these 4 types, we have 2 different options. One of these options is the communication interface. If none is selected, that doesn't mean that there is no communication interface. All SYNCHROTACT 6 devices have a communication interface to connect the program for maintenance and commissioning, SynView 6. And this can always be done, but for operation, it can be selected. There is a selection between IEC 61850 electrical or optical connector, or Modbus or Profibus. And then the second option is functionality. Devices are available with 2 parameter sets or 20 parameter sets. Now, I thought you might like to hear what one of our customers says about SYNCHROTACT 6. This is a pilot installation at the 3.5 megawatt Schiffmühle hydropower plant in Switzerland. As you can tell from the 2 quotes, the customer is very satisfied. And I have to say, I personally was involved in this project, and it was our very, very first SYNCHROTACT 6 commissioning. And because it was a pilot project and SYNCHROTACT 6 was not yet released, and the customer was afraid of upcoming problems with the new product, and therefore he didn't wish to replace the old SYNCHROTACT 3, but he wanted to add the SYNCHROTACT 6 in the existing cabinet. And then he wanted to have also a 2-position selector switch, 1 position for SYNCHROTACT 3 and the other for SYNCHROTACT 6. And during my last contact with the customer about a year ago or so, he told me that they never used SYNCHROTACT 3 position again after commissioning of the SYNCHROTACT 6. Now, ABB has a dedicated service and support network, providing 24 hours, 7 days a week support for excitation and synchronizing customers across all regions of the world. We offer a flexible and comprehensive service offering, help you to secure SYNCHROTACT availability and maximize its life cycle. Our service portfolio ranges from spare parts to turnkey solutions. We can also help you with a variety of services, including selecting the right SYNCHROTACT type and options or an equivalent replacement, engineering, parameterizing, installation and commissioning, and training. And for training, in addition to the local training courses that ABB provides at the ABB University, we can provide remote training accessing our SYNCHROTACT 6 simulators. In summary, SYNCHROTACT 6 is a tried and tested technology now in its 6th generation with more than 24,000 units sold worldwide over the past 55 years. It has an exceptional operating range for generators from 1 megawatt to the largest 2,000 megawatt machines. Its 3 standout benefits are safety with a diverse dual channel design, flexibility with 20 parameter sets, and the life cycle. SYNCHROTACT 6 provides easy and cost-effective upgrades of all the SYNCHROTACT devices, including installation and commissioning. With ABB's global service and support network and training programs, you are in the best hands. Now, please contact us using the local ABB office or directly with the links given on this slide. Now, this is the end of my presentation. Thank you for your time and attention. I would now be happy to answer any questions. So, Barbara, you can take over, please.
Yes, for sure. Thank you, Werner. Thanks a lot for your comprehensive presentation. We have quite some questions coming through the chat, so let's go in order. I'll try to read them out. In some cases, there are some acronyms which are not completely sure, so I'll read the question exactly as the person asked it. So the first question is, can SYNCHROTACT target to close the circuit breaker at 5° positive side if the customer needs it?
Sorry, at 5, can we close at
5° positive side if the customer needs it?
Yes, this can be done, but maybe it is not usual. I mean, it will give the command before phase coincidence to compensate the delay time. This is, however, not a fixed angle. But of course, the measuring could also be adjusted so that a fixed angle difference could be set.
Perfect. Thank you, Werner.
Yeah.
Second question is, what could be the longest distance for the VT connection to SYNCHROTACT to have errorless synchronization?
Yeah, this is I can't say a distance, an exact distance or something. However, SYNCHROTACT needs an AC voltage which is about the nominal voltage shall be between 50 and 130 volt. If this is possible, then it's no problem. And also, of course, sometimes the distance between one voltage and the other voltage might be different in its length, and then this can be compensated. So, but it is important, of course, that the voltage, I mean the phase angles and frequency and so are somehow at least constant or correct. Better if it is correct.
Thank you.
Yes.
Then next question is about the flexibility section you mentioned. During the flexibility part, you mentioned that SYNCHROTACT can sync up to 20 generators. Can this be synced automatically with preset timing, or do they need manual intervention?
To select it or what? I didn't get.
I think the person is asking whether to sync these 20 generators, you can do them automatically with preset timing, or if they have to be set manually every time.
No, I mean the presetting of the parameters is for every circuit breaker. It is individual. The settings are in the parameter sets. But of course, you have at a certain time you have to select. I want to synchronize parameter generator number 7, and then you have to give the signal to the binary input, which will select parameter set 7, and then everything goes. And how to select that? That can of course be automatic or not. It doesn't matter. The signal must just arrive on the binary input in order to know which parameter set and which paralleling point or circuit breaker has to be synchronized. But where this information is initiated, this is not of interest from SYNCHROTACT point of view.
Thank you.
Now it is project Schiffmühle that I mentioned. There is, for example, based on the water level, they are synchronizing one machine plus or minus. They have 3 machines, and depending on the situation in the water level, they are synchronizing one machine more or taking one out from the grid. And this is automatically done. This is not made by human.
Thank you, Werner. Next question is it allowed to replace any failed card individually?
What individual?
Failed cards. I'm reading exactly what our attendee wrote. If the question isn't clear, we can maybe go to the next one.
Yeah, I couldn't get the replace a face.
Failed cards. No worries, we can go to the next question.
Okay. Yeah,
and
please.
address
I
this
can
individual.
I can answer later if
Exactly.
Yeah.
So we will locate the person who has asked the question and ask him or her for more details so that we can address it. So next question is safety functionality, for example, 2002, an optional or standard functionality?
The 2 out of 2 2 out of 2 process is only available with the dual channel devices, because of course there have to be 2 deciders and both must agree. So it means a single channel devices don't have that. But of course we are also, like other, we are recommending to have a synchro check at least in series with a single channel automatic synchronizers in order to have a safe synchronization. So in some cases where there is already one synchro check and an auto synchronizer, maybe in different cabinets, and only one is replaced, it can be replaced with one single channel SYNCHROTACT 6, for example, the auto synchronizer, and it is still, the whole system is still a 2 out of 2, but not in the SYNCHROTACT itself. It's not a 2 out of 2 then. So 6201 and 6200, these are not 2 out of 2. Just if you just look at the SYNCHROTACT itself.
Thank you. So the next question is SYNCHROTACT products suitable for both AVR and governor control, means both active and reactive control?
So, I mean, the SYNCHROTACT is measuring the actual value. So it means the conditions on the circuit breaker, and one of the 2 PTs is delivering the voltage of the generator, voltage and frequency of the generator. And it is measuring this, but it is not regulating or controlling directly the voltage, for example, but the AVR is regulating the voltage based on the set point the AVR has. And what the SYNCHROTACT is doing, if the voltage, for example, has to be increased, it will change the set point of the AVR, increase the set point, and then the voltage regulator will increase the generator voltage, and finally the result is measured by SYNCHROTACT and checked whether this is enough or more is needed.
Thank you. Next question. Does the repair of error in SYNCHROTACT need an offline operation, or it can be done while online?
Yeah, this depends. I mean, generally we have the possibility to send a reset from remote to reset an error. However, it depends, of course, what is the reason for this error. If, for example, the synchronizer is started, but when the machine is not running, it cannot synchronize. It will try, and after a while, there will be maybe a timeout, and the SYNCHROTACT goes into error. It can be reset, because, of course, it's an external problem. It can also be an internal problem if there is something not working properly. It can be reset, but if the, for example, power supply goes out of the device, then it cannot be reset. But it depends on the kind of error that is present. But generally, we can, or at least can try to reset the error and to go back to it. Or with the 6302, it can be a remote bypassing of one of the devices. The two devices in the 6302, they have its own power supply, for example. So it is fully redundant. And so with this way, it can has a very good what's the word? Redundancy. Sorry.
No worries. Very good. Thanks a lot. There are still questions coming. We will try to address another couple of ones at least. As indicated, SYNCHROTACT 6202 has automatic synchronization and SYNCHROCHECK in the same box. Does this mean that these both functions are part of the same controller, or the product has double controllers?
The 6202 has two controllers, and it has for each channel one, and both have always to carry out the same functionality. And it can be used, the SYNCHROTACT 6202 can be used for automatic synchronizing. This is the normal way. It can also be used for manual synchronization. In this case, channel one is using a parameter set which is programmed to work only as SYNCHROCHECK. And then we have two SYNCHROCHECK in series. Channel 2 is always a SYNCHROCHECK function, and two SYNCHROCHECKs are in series then, and it can be used for manual synchronization. However, of course, when the manual synchronization is used in case the synchronizer wouldn't work, in this case, of course, also the manual synchronization will also not work, most probably. So therefore, for real good redundancy, a different system like a 6302 or a manual and an auto synchronizer in parallel to be switched from one to the other system, this is a good solution for a good redundancy. But the two channels themselves, they are mandatorily in series. That means you cannot use a 6202 and only use one of the two channels. And also the power supply has only one. It is not for redundancy, it's only for safety. And if you could bypass it, you would reduce the safety by far. And that's for the safety concept. It is important to have this mandatorily in series.
Thank you. So we can take maybe another question. Can SYNCHROTACT act as protection against reverse power supply from grid to generator?
Whether it has protection functions?
Yes.
No, it has not really a protection function. It has it is protecting. It's maybe it could be misleading. It is not a protection equipment, but it is just preventing an accident or something in case the circuit breaker would close due to an error, would close in the wrong moment. It would not close. So, but the protection when it is running to trip the circuit breaker, I mean to open the circuit breaker, this is not part of the SYNCHROTACT. And I think it's also good to have this safety-related function separated from other functions, because the more complex a system is, the more the safety is ensured.
Thank you. So let's see, there are quite some more questions and we won't be able to cover them all, but as anticipated, we will go back to the people who asked the question. We have your contact and be sure to provide you with an answer. So I suggest to take one last question, which is actually more a request for clarification, and is, so SYNCHROTACT can initiate set points of ADR and governor of incoming generator to match synchronization condition.
Sorry, I didn't get all it. The sound was somehow disturbed.
I'm sorry, maybe my connection is not super good. No worries. So SYNCHROTACT can initiate set points for ADRs and governor of incoming generators to match synchronization conditions. It's not a question. It's most probably a request for confirmation.
Yes. Yeah, it is not initiating, but it can move it up or down. So I mean the set point itself is with the AVR or the governor, and this system is running independent from the SYNCHROTACT. Only when a synchronizing process is started, then the SYNCHROTACT has the possibility to move this set point of the AVR or of the governor up and down in order to adapt the voltage and the frequency.
Thank you. Let's see, maybe there's time for one more question. Okay, trying to understand what the actual question is, so I'm hoping I'm interpreting correctly. So can SYNCHROTACT be installed at the moment of the plant build, I guess, or can it be even included in the plant planning? I guess that was the question.
Yeah, of course. I mean, how I'm not sure whether I understood correct, but it is not the question how many devices shall be used in a power plant. This is not, I mean, given by the SYNCHROTACT. It can be decided for some reason. It can be decided to have only one synchronizer for one generator unit, for example, with maybe 2 or 3 circuit breakers, maybe a high voltage or a unit circuit breaker or things like that. This can be done with one synchronizer, and for the other generator, which is maybe 50 meters away, another synchronizer can be used. This is open. We provide with our parameter sets, we provide flexibility, but of course it also depends which is the best solution, depends on the architecture of the plant. So to bring all, if it is already existing, then to bring all the measuring circuits to one central point might be at the end more expensive depending on the plant. So the best is maybe to make groups of different circuit breakers which are close together, and to use one synchronizer for that. But as we are selling for all the different power plants and substations in the world, we cannot really say. We can only provide the flexibility to do it as it is in the best way.
Thank you, Werner.
You're welcome.
I think we are at the end of our time. So I want to thank you, Werner, for taking all this question and again for the comprehensive presentation. Let me also thank all participants for being with us. Once again, the questions we didn't manage to answer will be addressed separately, individually. And you will be receiving in a couple of days the recording of this webinar. So if you want to hear it once again, you can do it at your own pace. You can forward it to anybody you think may be interested. You'll also find the contacts to contact us directly if you're interested in understanding more, if you want clarification, or if you want more information about it. So once again, thanks for being with us. Wish you all a good evening, a good afternoon, or a good day if you're in the Americas. Thank you very much again for being with us. We will have more webinars about excitation and synchronization, and in general about the changing power landscape. Thanks again.
Thank you. Bye-bye. Yeah. Thank you.
Bye.